Claude Opus 5 is here, and Anthropic is pitching it as the model for complex agentic coding and enterprise work. The headline numbers are big: 1 million tokens of context, up to 128,000 output tokens, thinking enabled by default, and 5 effort levels that go all the way to max. Those specifications do not tell you what happens when the model meets real tooling. I approved one controlled coding run on a synthetic JavaScript fixture. The tests were real, the permissions were narrow, and Claude Code reported every token. Then the background process appeared to die, a foreground retry started, and both Opus invocations quietly overlapped on the same file. The code passed. The usage doubled. And the most useful lesson had less to do with benchmarks than with orchestration. Opus 5 replaces Opus 4.8 at the same standard API price, $5 per million input tokens and $25 per million output tokens. Fast mode doubles that to $10 and $50. Both observed runs used standard speed, not fast mode. The model has a 1 million token context window with no smaller Opus 5 variant. Maximum output is 128,000 tokens in the API documentation. Claude Code reported a 64,000 token output ceiling for these runs, which is a client configuration detail rather than a contradiction in the model specification. Thinking is now on by default. Instead of manually enabling it, developers control depth with low, medium, high, or max effort. Anthropic also says Opus 5 verifies its work more often and delegates to subagents more readily. That deeper behavior showed up clearly, perhaps more clearly than intended. The fixture was a small JavaScript billing module. It splits a fixed cart discount across line items in proportion to each line's subtotal. Money makes rounding bugs annoying. If 3 lines deserve fractions of a cent, independent rounding can lose a cent or create an extra one. The correct implementation must use integer cents, cap the discount at the subtotal, distribute leftover cents with the largest remainder method, and resolve exact ties by line order. The original implementation used math.round on every line independently. 5 tests covered exact totals, deterministic tie handling, discount caps, input immutability, and invalid discounts. Before either invocation touched the file, 3 tests passed and 2 failed. Opus could read the 4 synthetic files, edit the implementation, and run npm test. It could not browse the web or modify the tests. The first invocation started in a background wrapper. After about 20 seconds, the process manager reported it as exited with no code and no output. The receipt files were still empty, and the fixture still showed 3 passing and 2 failing tests. So the same approved task was retried in the foreground. That looked reasonable at the time. It was wrong. The original Claude child had not stopped. It continued outside the process manager's view. The first invocation eventually completed in 2 minutes and 24 seconds, using 18 agent turns and about 82 cents of API equivalent usage. Its receipt correctly recorded the 3-pass, 2-fail baseline and a 5-pass final result. The foreground invocation ran for 5 minutes and 55 seconds across 25 turns. By the time it checked the suite, the other process had already been editing the same implementation. It saw green tests, audited the code further, and explored validation and large number precision cases. Both invocations targeted billing.js concurrently. The final implementation uses largest remainder allocation, validates malformed lines, and uses big int for exact high-value share calculations. The tests were never modified, and only billing.js changed. But because the processes overlapped, the final lines cannot be cleanly attributed to one invocation. The final suite passed, 5 tests green, 0 failing. I ran it again outside Claude Code and got the same result. The repair is technically sound. Independent rounding was replaced with deterministic largest remainder allocation. Exact ties favor earlier lines. Discounts are capped, totals do not go negative, and the public API remains intact. The second Opus report said the suite was already green before it changed anything. That initially looked like the model had rewritten the baseline. The delayed first receipt changed the interpretation. Green was probably the state the second process actually observed after the first process edited the shared file. So this is not evidence that Opus hallucinated the test history. It is evidence that a process manager can lose track of a child while the child continues consuming quota and modifying files. The code result is valid. The experiment is not a clean single-run benchmark. That distinction matters. The first invocation reported 430 fresh input tokens, 35,399 one-hour cache creation tokens, 418,368 cache read tokens, and 10,009 output tokens. Its API equivalent cost was about 82 cents. The foreground retry reported 123 fresh input tokens, 34,605 cache creation tokens, 863,591 cache read tokens, and 25,300 output tokens. Its equivalent cost was $1.41. Combined, the two invocations used 553 fresh input tokens, 70,004 cache creation tokens, 1,281,959 cache read tokens, and 35,309 output tokens across 43 agent turns. Total API equivalent usage was $2.23. An existing Claude team subscription handled both calls, so there was no separate API invoice created for the video. These dollar figures come from Claude Code's own equivalent cost receipts. The important number is not just cost. It is duplicate work. A retry launched because the wrapper looked dead, while the original model call kept running. In an automated system, that pattern can burn quota, race on files, and produce a final state with unclear authorship. Use unique worktrees, idempotency keys where available, per-run output directories, and explicit child process termination. Never treat an empty log as proof that the model call stopped. A 1 million token window is useful when the task genuinely spans a large repository, architecture documents, logs, migration plans, or a long-running agent session. It is unnecessary for a 4-file fixture. The effort ladder matters for the same reason. Low or medium effort should suit routine edits and straightforward questions. High, and max make more sense when a wrong answer is expensive or the task requires exploration across many files and tools. Opus 5 supports image input, prompt caching, tool use, and large outputs. Anthropic added mid-conversation tool changes in beta, so applications can alter the tool list without throwing away the existing prompt cache. Fast mode is available as a research preview on the Claude API, but its price is double and it was not used here. The practical lesson is to match model, effort, context, and process isolation to the work. A powerful model cannot protect a pipeline from launching the same job twice. Opus 5 solved the billing problem. The final implementation passed every original test, preserved the public API, and added technically credible protection for malformed inputs and large number precision. But this run cannot support a clean claim that Opus needed one specific duration or one specific cost. Two invocations overlapped because the first wrapper reported a false exit. Their separate receipts are real. The combined usage is real. Attribution between them is not clean. That leaves two verdicts. On the model, capable, thorough, and willing to investigate beyond the tests. On the workflow, unsafe until retries are isolated and the original child process is confirmed dead. Opus 5 passed the code test. The pipeline failed the concurrency test. In production agent systems, both results count.